Today we're going to solve some equations, some linear equations, using the distributive property. So if you're not familiar with the distributive property, you should probably go back and watch the video I've got on the distributive property, because without that, you won't be able to do some of these problems. I'm actually going to show you two techniques for solving equations that look like this, but I've only kind of got the instructions up for when we use the distributive property. So our first step is going to be to just distribute. Right? So we should know how to do that. We should take this 3 and multiply by the 2x, giving us 6x, and the 3 times the 5, giving us 15. And we'll just keep the right-hand side as it is. 6x plus 15 equals 45. And from here, the second step says combine like terms. Now, we don't have any like terms here to combine, so we'll skip step 2. But now it's just a regular linear equation where you've got some stuff attached to the variable, like the 6 is attached to the x, and you got some stuff on that same side that's not attached to the variable, like the plus 15. So if you remember how to solve these from before, the first step here now is going to be get rid of the stuff that's not attached to the variable. So the opposite operation of plus 15 is minus 15. So we'll do that to both sides. On the left side, we'll have 6x. And on the right-hand side, we'll have 30. Then we'll just divide by that coefficient of 6 and get our final answer of x equals 5. Now, real quickly, I'm going to show you another way that we could go about doing this problem if we wanted to. Now, you don't have to do it this way, but if you prefer this, now here was our original problem. It was 3 times 2x plus 5 equals 45. And this, for this particular example, this method works just fine. We should note that the sign between the 3 and all this stuff in the parentheses here is multiplication. So we can still do an opposite operation here. Right? We could just divide both sides by 3. And when I do that, 3 divided by 3 is just 1. Those cancel out, and we're left with 2x plus 5 equals 45 divided by 3, which is 15. Now, chances are, if that number on the right-hand side, that 45, didn't divide nicely by this number out here, the 3, then we're probably not going to want to use this method, because then we end up with a fraction right off the bat that we're going to have to deal with as we solve this. Right? But since 45 divides nicely by 3, there's nothing wrong with dividing both sides by 3 first. Now it looks just like a two-step linear equation. We'll subtract 5, giving us 2x equals 10, and then we'll divide by 2, giving us x equals 5, which we'll note is the exact same answer we got when we did it the other way, right? We got x equals 5 the other way. And we got x equals 5 this way, which makes sense. We should get the same answer no matter which way we solve it, because there can only be one solution to a linear equation. So we'll do a couple more of these, and we can probably just do them all both ways. Might as well. We'll start off with just distributing the negative 2 here. Negative 2 times 4x is negative 8x, and negative 2 times 8 is negative 16. So we have negative 8x minus 16 equals 24. And now it's just a regular two-step linear equation. Add the 16 to both sides. Gives you negative 8x equals 40. 24 plus 16 is 40. And then you divide by the negative 8. Remembering that when you divide by a negative, a positive by a negative, you get a negative. So our final answer will be x equals negative 5. And just to show that we could have done this the other way as well, negative 2 times 4x plus 8 equals 24. Same problem. We could have divided both sides by negative 2 to start with. Right? So that would just give us 4x plus 8 equals negative 12. when we subtracted 8 this time, we'd get 4x equals negative 20. And then when we divided by 4, we would get the same answer, x equals negative 5. So we can see that regardless of which method we choose, we're going to get the same answer every time. And of course, you can always go back and plug your answer in. Go plug that into the x value there and show that it does work out. Now, we're not going to show that this time, but you can always check your work out. For this one, we'll just do the distributing method. I'm not going to bother to divide by the 3. We could divide by 3 because 75 is nicely divisible by 3, but we'll just do the distributing method this time. 3 times 3x is 9x, and 3 times minus 5 is minus 15. So we have 9x minus 15 equals 75. When we add 15 to both sides, we get 9x equals 90. Okay? And then we'll just divide by that coefficient of 9, giving us x equals 90 divided by 9, which is just 10. So we'll do a couple more here. Now, we've got some options here, but I'm going to show you the way that I prefer to solve these, which is just to distribute first and then combine the like terms. So if I distribute negative 5 to 2x, I get negative 10x. And negative 5 to 3, I get negative 15. I still have the plus 10. I don't want to forget to write that. And it equals 75. Now this time we do have a like term here, right? If I go through my normal combining like terms process, I'll underline the x and any other x terms. I don't have any other x terms on that side, but I do have 2 different constants. So this can turn into negative 10x, and then negative 15 plus 10 is negative 5. So negative 10x minus 5 equals 75. Then we'll just treat it like a regular 2-step linear equation. We'll add 5 to both sides. I'm going to write the result up here. The negative 10x will just stay, right? Negative 10x. The negative 5 plus the 5 goes away. And 75 plus 5 is 80. When we divide by negative 10, we end up with x equals negative 8. And so we'll do one more. Distribute it through. 3 times 4x is 12x. 3 times minus 3 is minus 9. And then we have the plus 7 and equals 70. Combine your like terms. No like terms with the 12x, but we do have 2 different constant terms that will combine together. So 12x. And then minus 9 plus 7 is minus 2. It still equals 70. When we add 2 to both sides, we end up with 12x equals 72. And then you can just divide by 12 to get x equals 6. And that's how you solve linear equations using the distributive property.